Good afternoon, everybody. And it's pleasure to be here to share our viewpoint, our association with OCP, and see how our observation on how it progressed. So in next 20 minutes, I would focus on a little bit how we are involved with OCP, how we view that OCP is going to grow and what needs to be done. That's I'd share our position, our perspective on that. Secondly, I will walk you through all the products that we are coming up this year or have come up recently, and what we are going to do in next few years, and how important the openness in these products um, is to us, and how much investment we are doing to make these components open to industry. So first, let me, and by the way, again, my name is Krishna Paul, and I am a technologist. I've been working with Intel for last 16 years. I'm a technologist in data center group. I have been developing a lot of core IPs which has gone to market. Today I am representing Intel's viewpoint on OCP and sharing with you all the product lines. So first, let me take through what she just shared. Thank you for that. We have been founding member for last 10 years, and tremendous amount of contributions we have seen from ourselves and from the community, and 80 plus product partners. So it's a really big pleasure for us that what we started as key partner has really taken us feet, and people are appreciating. So I learned, I'm also ramping up, and I learned that today, as of today, it's around $3 billion business for OCP products, and in next 4 years, possibly it is going to be $10 billion of products, right? So from Intel position, who kind of nurtured it from the beginning, we are thinking what are important aspects to take advantage of this growth, how we should support this movement, and while there is so many things in horizon, we have to prioritize our viewpoint and work towards it. So that's where, based on all the customer feedback and what we are getting to see, and especially in the world of data deluge, and we are possibly in the cusp of a huge digital revolution for human society, which we have never experienced before this. So it's a very important time. And in this important time, sorry, and in this important time, I'm going to about top 3 things that's very important to Intel, and that's the lens we are wearing to understand the surrounding around us, and that's where we are focusing in making our products. First is workload. So we are seeing that although, I just heard that hardware changes every 6 months, we have another opinion, software is soft. So software changes very frequently. So, and we are struggling like to keep up with software. And for hardware, so what our viewpoint has changed. So now we go and try to understand workload very well, and the world is moving towards specialized hardware. So in order to make specialized hardware, we are seeing that understanding of workload is critical, and there, analytics is the biggest workload. Now, I'm sharing Intel viewpoint on workloads. So it's our observation and opinion, and that's where we'll put our box on analytics workload. Second is that, so that means what? So there's a huge demand in computation, so data servers, data centers are growing, that's where the money is, that's where world is going. And hence, in addition to that, we need very open management system to manage all of this. And thirdly, it should be integrated solution in the sense that, not one house will have all the IPs. It is going to be a heterogeneous system, and hence the integrability between components and ease of deployment are very important. So these are the 3 tenets on which we are basing our product concept today and going forward in future. So the reason I spoke about three things, I will take you our products through our product portfolio, how we are trying to support those three tenets. So first, let me go to CPUs. So in the first half of this year, we launched Cascade Lake, which is, this is OCP compliant, and basically, you know about Mount Olympus server design Microsoft project. They are refreshing their design based on Cascade Lake processor. So Cascade Lake processor is the current generation which we just launched, and so it has very famous octane persistent memory. We'll talk about that little bit more. And then it has deep learning acceleration. So we are not only thinking about CPUs, we are also thinking about how we adopt these CPUs to workload. So we have DL boost here. In the previous generation, the whatever work was being done by 3 instruction, now we are able to do with new instruction with single instruction. As a result, CPU inferencing performance has improved 10x more than the current generation. So that's third key thing. And first being, of course, the Optane memory. Now, and in terms of platform, we are being OCP compliant and part of Mount Olympus design. Now, that's clear example of that we are designing CPUs which can speed up workloads. Now, second comes, let me take you to Cooper Lake processor platforms. So this is a project co-designed with Facebook, and the main requirement was configurability. So configurability in the sense of that more sockets, more CPUs. So typically OCP community has seen 1U or 2U or 1 socket and 4 socket configuration. This one can go up to 4 socket, 8 socket, depending on the need. That means the whole thing is driven by that I need huge scalability in terms of workload, and I should be able to design as per my requirement. So Cooper Lake is one such system. It's specially designed for the machine learning workload. It also has FPGA attached to it and a very high speed interconnect to the CPU. So if they want to do network workload offload, they can do it very easily. And because of the very high speed interconnect and a lot of memory, local memory around it, you can compute heterogeneous kind of workload or downloading, offloading the infrastructure workload very easily. I missed one point. The Cascade Lake also has Cerberus root of trust, which is again OCP-based things. This is just launched, Cascade Lake, and this is second half of 2019. So that was from workload perspective. The another viewpoint we are taking is that trying to understand the pain of cloud customers. And so this is a particular platform design. So you can see this is a 2U based design, which has 4 sockets. So it is about infrastructure efficiency. So for infrastructure efficiency, you can see that 4 socket based design, and it has 48 DIMMs. That means a huge loads of memory. And it also has Optane, and available in second half of 2019. This is purpose built with the initial spec is donated by Inspur. They are our co-partner, and the purpose of this was to increase the efficiency of cloud infrastructure, and increasing VM density to next level. So and you can use 112 cores here. So basically, you have huge amount of cores in the same space, and as a result, you can increase your VM density to very high level. So and the cost remains same or at lower cost, power performance. So the whole point was that cloud infrastructure should benefit by doing lot more compute in much lesser space. And this one also is going to come. We are in works at it. Now, so moving a little bit beyond CPUs, world is moving towards heterogeneous compute, offloads. So this is our offering for machine learning. So this is Intel Nirvana neural network processor. On the left side, you are seeing the chip, which is for training purpose, and on the right side, it is inferencing. This one is based on Spring Crest class of products. So this has huge number of, this is based on upcoming CPUs, and this has huge amount of local SRAM and huge amount of high bandwidth memory between CPU and the training chip. So because of so large memory, you can download huge size of data models to the chip, and is not limited by resource, so you can do it faster. So this is for training workloads. And then on the right side, you see products based on Spring Crest, which is for inferencing based on 10 nanometer process. And these two chips will come out 2019, end of 2019. So this is mezzanine form factor, and this is M2 form factor. So standardized form factor so that you can easily plug in. And they are connected with CPU with high-speed bus. And now, most important thing is Intel is a proud partner of Facebook Glow community. So it's important to build very high efficient chips, but as well as we participate in optimizing AI frameworks for our hardware, and we are heavily investing in that. Some of the example is PyTorch and Cafe 2. We are working with Facebook to get the best performance out of these two hardware. So there are running projects on this. So that was about a chip which is not CPU and meant for AI workload. Again, so I'll go back to the thought of that. We also view that this system, this world is going towards multi-computing, parallel computing, and heterogeneous computing, and hence it is important to make other devices along with CPU, but unless you make very high-speed interconnect from CPU to device, it's not going to work. And that's where Intel is taking lead, and it has come up with a new specification called Computer Express Link, which is launched just 2 months back, and we are inviting OCP community to participate in that. And this is basically a CPU to device interconnect based on PCI Gen 5, and it will create a huge space for coherent memories between CPU and device, and it is essentially to expedite and making it efficient, all offload kind of compute, CPU device co-compute, and hence the proposition of this specification. So the first specification is donated by Intel, and all these are key partners, Google, Microsoft, for us. And Intel products in 2029 is going to come out with this interface, along with all the AI chips and storage, networking that you are going to hear. So it's very important that we ramp up on this specification and see how open. This is open standard. So OCP is not about a particular spec, but I think this is a mindset that the interfaces to hardware has to be open. So from that perspective, this is in the same ethos of OCP. So that was about the link. Link. And then, eventually I'm going to walk through all the components in a platform that Intel is coming up with. So this one is NIC. I'll just say, so it was wonderful, inspiring talk by Mellanox. This is what our Intel offering is. So you can see that 10 GB, 25 GB, 40 GB are OCP compliant. We have 1 GB and 10 GB in OCP NIC 3.0 specification, but by the end of the year, we'll have the whole range of 10 GB to 400 GB compliant to OCP NIC 3.0. So this is what we are doing. We are heavily focusing on offload. We agree to the concept of offloading infrastructure to smart NICs, and we are coming up with products which works best with Intel CPUs and give differentiated value in the space. So in all of these, when you look at all these hardware components, yeah, so the world is about being open. So we are inviting all of you to work with this upcoming new Intel hardware. We are part of OpenSpec, and the more you experiment, the more you do proof of concepts with this, we get better results, and we get integrated with others more easily. So this one I will just touch upon. This is silicon photonics. We have been shipping 100 CWT, 100 gigabit CWT-M4 OCP form factors and OCP interfaces. But by the end of 2019, we'll move to 400 gig. It is very important for data centers. And so basically, being open means we are trying to see, so you have to plug these modules, optical modules, to your ASICs, and so there is an interface and we need to standardize it. So working to standardize electrical interface die to die, as well as switch ASIC to the optical module, and this is going to be driven by open standard and open standard specification of interfaces. Okay, this is the most interesting part. So this is a huge deal for Intel, and we have redefined our storage hierarchy and persistent memory, Optane persistent memory. So you can see our hierarchy, and one of the very interesting thing is that this Optane persistent memory has different modes. One of the mode is that you can use this as RAM, but at much lower cost. So your memory capacity bound applications can work better at lower cost. So this is based on 3DX technology, and it's a revolutionary technology which all the platforms that I spoke about is coming with Optane persistent memory. You can also use at a different application direct mode, where application can see this memory and RAM separately, and can make use of it, and you will see the storage based application like database application, in database application, improving performance to a huge deal. One of the, from business aspect, you get much more better efficiency at much lower cost. So I'll speed up. I knew that I won't be able to cover all of this, so let me skim through. So until now, we have been talking about all these products that I spoke about is what we are doing in terms of workload optimization. Not only CPU, we are standardizing the interfaces and making other components which is specific to workload. So, but what we are doing on open management, what we are doing in open management is, this arrow is misplaced. Yeah. So this is Intel rack scale design. My previous speaker was mentioning about it. So of course, I am not going to repeat this. This is new thinking, that we pool our resources for better cost efficiency, and we compose the system as the demand comes by. And for that, you need standardized software to talk to the hardware. You need changes in the hardware so that it can respond to this composition request. So this is evident that all of our components that we spoke about has hardware changes in it. To be able to support RSD, this is open, and this is our Intel RSD 2.0 specification. And you can see switches, compute, storage. Intel has very significant specification at a very mature state. We have done demos of it. In the interest of time, you can talk to me later for details of it. So if you look at firmware, first speaker, Vijay spoke about it. So you guys do not see hardware. All you see is set of interface. What's there on that side of interface, whether it's a human or a hardware, it doesn't matter. That's commodity. So the focus, when we talk about all this topic, huge views at Intel invested in all these trees, and which is integral part of OCP, system firmware, OCP compliance. So I don't exactly as a technology work in this, but I see my colleagues going to this place and very excited. And then BMC, Open BMC firmware, I think from that team, 7 people are here. Linux, so we take care of Linux foundation project as well as Open BMC GitHub. And then rack management firmware, which is, so RST 2.3 is not in contradiction with OpenRMC project. So we are all aligned with this firmware that Vijay mentioned in the morning, while we change underlying hardware to make a composable system. So, root of trust, again I'm skimming through this. So Intel is providing hardware, so no better place of security than doing security in hardware. So here also we are trying to be standard compliant. You can see NIST as a foundation for doing all of this, and we are investing heavily in giving security in all that we do, including CPU, GPU, FPGA, and NIC. Intel is also invested in CPU. So all these different pieces of hardware will have root of trust and a standardized API for programmers to access those key management systems. So last but not the least, so all these names are not exactly OCP name, but the feeling and the ethos is the same. This is about standardization. This is about being open. So we have huge software division investment in working on this project. And this is about servers. So on the left side, you see we are working with Kata containers isolation. It's all about security. And then NEMO, which is about giving very lightweight VMs. And then orchestration software, we are deep entrenched into OpenStack systems with Kubernetes. And then the call of the day is on the right side. Optimizing for cafes. So huge, army of technologists work in optimizing these open source AI framework and showcase Intel hardware benefits. So basically, we understand these models very well, and we design our hardware instructions so that we can speed up this. And all this cannot happen unless we are heavily involved in standard framework. So that's about it. Thank you very much. Before ending, I would like to bring in my India hat. So I just heard that India is not picking up in compute, and we do not need such fast switches. I don't think so. Even if we are not needing now, it's going to burst in next 3 to 4 years. And if you look at India, it will be the one to lead that data deluge world that we see. That's where India will lead. So Intel India is heavily invested in autonomous driving. We have collected the traffic data around this. This is one of the very key data sets of internationally, and algorithms that were working on the Western data set are flatly failing on that data set. And this is like 10 times more than the Western data sets. And that's the reason I gave that example, is to give you an example what India can do in this data deluge story and why most competitive hardware needs to be deployed here. And if that is true, we as a community needs to collaborate here by frequently inviting Vijay and team and create a very successful community here. Thank you very much.